Hi guys, welcome back to my channel Pirai Academy. In the series of Soliton interview question, today we are going to see about a question called find perfect square in the given array. So it is categorized into the easy problem, and it is pretty much easy problem to solve in the brute force approach. But if you want to solve in the optimized approach, it will be slightly medium level, like that, easy medium level. Okay, it is not much hard. Okay, fine. Now in this question, they will be given you a array, an integer array of positive integers, and you want to tell them what are all the numbers or what are all the elements that are perfect square inside this array, and you want to print them. For example, if they have given this array, then what are all the perfect square we have? It is 1, 4, 9, 16. So what is meant by perfect square? So perfect square number is something in which we want to square some other number so that it will be resulting in the current number, which means for example 2 into 2, which is equal to 4. So 4 is a perfect square, right? And then 9, then if I root this 9, then it will be 3. So 9 is the perfect square because 3 into 3, which is equal to 9. Hope you understand this. So squaring 3 means it is 3 into 3, which is equal to 9. So that's why we are just selecting these 4 numbers alone from this given array. Can you understand this? Yes. Now how to just determine whether it is a perfect square or not? Okay, it's pretty much simple, right? It is pretty much simple. See here, if the given number is, for example, it is 9. Okay, I don't want to say all the numbers. I'm just taking one number and explaining to you with the brute force approach. Initially we can see the brute force approach. So initially it is 9. Okay, then I want to just come from 1 up to 9, and I want to check whether 1 into 1 is equal to 9, 2 into 2 is equal to 9, 3 into 3 is equal to 9. Yes, it is 9. So I will be returning true. Hope you understand this. Can you understand this? So initially 1 into 1 is equal to 1, 2 into 2, which is equal to 4, 3 into 3, which is equal to 9. So now I encountered this value. Okay. If, for example, if the given value is 6, then 1 into 1 is equal to 1, 2 into 2, which is equal to 4, 3 into 3, which is equal to 9. 9 is greater than 6, right? So we do not get any other possible values for this 6 in the right side of these elements. Can you understand this? Okay. Now this is going to be my brute force approach. And what is my brute force approach? So what is going to be my time complexity? So time complexity will be going up to what? O of n into m. Okay. And space complexity will be O of 1. Why I am getting n into m? What is meant by n into m? So n will be standing for the number of elements, and m will be standing for the maximum element among them. Like here 16. Can you understand this? Yes. So this is going to be my time and space complexity analysis. Now, how can I optimize this approach? Whether I can still reduce my time complexity. In your coding interviews, like you are going for the technical round, okay, it is not a HR technical round, it is just a coding round. There you can use this brute force approach to just pass the test cases. But in your HR round, you will be just needing this optimized approach. Okay, and also just try to optimize each and every approaches, because it will be helpful once you are attending any other companies also. Okay, fine. Now what is going to be your optimized approach? Fine. So here we are just going with the range, right? We are just going with the range. What is the range? If, take for example, if I am going with the 9, I want to check whether this 9 is a perfect square or not. Then I will be having a range of 1 to 9. Pretty much okay. Now if I going for the 16, then I will be having 1 to 16. If I going for the 15, then I will be having 1 to 15. So I can tell you that there is a range, and those range are in a ascending order also. Then whenever there is a range and in a ascending order, we will be going to use what? Binary search instead of linear search. What we are going to do? We are just taking each and every value and squaring it and checking. Okay, it is what? Linear search. So this brute force approach is going to be my linear search approach. But now we are going to do what? Binary search. Okay, so how to do this binary search approach? So initially, let us take with an example of 9. Okay. Now initially my lower limit will be equal to what? 1. My upper limit will be equal to what? 9. In this range only, the perfect square number may occur. like for 9 it is 3, right? It may occur. Fine. Now I want to find what is the mid value. So to find the mid value, we have a formula like low plus upper limit minus lower limit here divided by 2. Hope you understand this. So for simplicity, we can also make this as lower limit plus upper limit by 2. So this is going to be my simplest mid formula, but when my upper limit reaches the int max, okay, then my lower limit is like 2 or 3, then it will be resulting in int max. Can I understand this? Or the upper limit is int max minus 1 and my lower limit is something like 3, then it will be going with the int max. So to avoid that, we will be using this formula. Hope you understand this. Okay, so always remember this as a formula. Now we are just going to find the mid. So initially, what is going to be my mid? So it will be 1 plus 9 minus 1 divided by 2, which is equal to 1 plus 8 by 2, which is equal to 1 plus 4, which is equal to 5. So 5 is going to be my first midpoint. Okay, so whether 5 into 5 is equal to what? 25. So whether it is equal to this 9? No. Whether it is greater than 9? Yes. Then it is like for example, take every elements up to 9. Okay, now I am at where? I am at this 5. Okay, if I go beyond this, whether any value will be yielding its square as 9. For 5 itself, for 5 square itself, it is exceeding 9. Then how can I go with the right side? So I will be making my upper limit to mid minus 1. Okay, so my upper limit will be mid minus 1, so it will be 4. Now again, this is going to be my lower and this is going to be my upper, right? Now what is going to be my mid? Now my mid will be like 1 plus 4 minus 1 divided by 2. So which is equal to 1 plus 3 by 2, which is equal to 2. Yes. So this is going to be my mid. Now check whether 2 into 2 is equal to 9. No, it is equal to 4. So 4 is less than 9. So which pointer should I move? I should be moving my lower pointer to mid plus 1. Hope you understand this. Can you understand this? Which means my lower pointer will be updated as what? 2. Now if I find, 2, it is 2, 3. Now if I find the mid value, what is going to be my mid value? Now my mid value going to be 3, right? Now if I do this, 3 into 3, which is equal to 9. So 9 is equal to the given value 9. So I will be returning what? True. That's it. Hope you understand this. So this is for one number. So we want to do for n numbers. Simple. So what is going to be my time complexity? It will be O of n into log of maximum number among those all. So log of 2, base 2. Okay. Now what is my space complexity? It will be going to be O of 1. So this is my time and space complexity analysis for this optimized solution. So in this Soliton interviews, you cannot use any inbuilt function except some of these inbuilt functions like string length, then scanf, printf. So this you can use, but apart from that, you cannot use any other functions. Okay, like square root. That is a square root method in C, but you cannot use that. Okay, it is not allowed, or it is restricted. So let us see the code so that it will be more clear. Okay, see this code. It is also in lead code problem. I think so. In lead code, I don't know exactly what is the problem name, but we have this problem in our lead code under the category of binary search. Okay, I will prefer a C programming language for Soliton interviews. So this is going to be our function to check whether the given number is a perfect square or not. Okay, now see here, initially my L is going to be 0, U is going to be N, and the mid value will be initialized. Yes, it is just declared. Okay, now while my lower is less than or equal to U. So why I am putting this condition is, I forgot to tell you, for some values like 5, okay, like 1 2 3 4 5, then I will be starting from here L, then here U. At some point, like let me change the color. At some point my U will be here, my L will be here. For example, it is what? It is overlap, which means U, the upper limit, is less than the lower limit. At this point we should be stopping and we will be returning what? No, this is not a perfect square. Hope you understand this. So this is going to be your false condition. I forgot to tell this, so just see this carefully. So here I will be taking the midpoint. Okay, so midpoint going to be L plus U minus L divided by 2. Okay, now I am just checking whether the current midpoint square is equal to the given number. Then I will be returning true, which means 1. If the square value is greater than n, then I want to just make my lower limit to mid minus 1. Else I want to make my upper, sorry, here I am just making my upper limit to mid minus 1, and here I am making the lower limit to mid plus 1. Okay, and then after finishing this entire loop, I want to just make my return pointer as false. It will be as 0. Okay, now here I am just going to traverse with the given array, and I am just checking whether the given any values is perfect square or not. If it is perfect square, I will be printing here. That's it. Can you understand this? But in that interview point of view, okay, in that assessment, you will be not given or initializing like this. They will be giving the array in any format. Like they will not be giving you the array size. Okay, they will be directly giving you the array. Then you want to get that array as a string format, and you want to extract each and every elements from that array and store in the your own array. Can you understand this? For that all input formats, I have given the separate video in the introduction video itself. You can go and watch that video so that you can clearly understand how to get inputs in a different formats. Okay, now let me just run this. Yes, can you see this? It is running successfully. So to know about these kinds of algorithms, just go and search in my YouTube channel. Don't skip any videos in this playlist, because every video will be helpful once you are appearing for the Soliton interviews. If you really like this video and subscribe to my channel. Thank you.